thanking everyone coming here, and it is not usually we have a guest coming from Africa to here give us a talk, and looks like the topic is very interesting to all of us, and so it's a very great honor to have Dr. Bolaji Segun Bolaji coming here to give us a lecture, and he's visiting me here at HAO, and I want to talk to him. Here's a brief bio for Dr. Bolaji, and Dr. Bolaji is from Lagos, Nigeria. In case you don't know, Lagos is one of the largest city in Nigeria. And, he got his PhD degree, he got his bachelor from Federal University of Technology in 2003, and he got his master at the same university in 2007, and he got his PhD degree in 2013 at the University of Illinois. At the same time, he also visiting trustee Italy at the International Center for Theoretical Physics. And, right now, he's teaching at the University of Lagos. At the same time, he also has affiliation with the University of Tasmania. He's visiting University of Tasmania. And he's interested mostly in the coupling of middle and upper atmosphere. And he has supervised 8 master degree students and also supervising 2 PhD students at the moment. And he also manages a space weather instrument network in Nigeria, and doing a lot of other things like being a member of Nigeria Institute of Physics, and also many other affiliations. And he wants to tell everyone he's happily married. He's a sweetheart and has very wonderful children. And today's talk, he's going to talk about solar quiet current response in Africa sector due to a 2009 Southern Stratosphere warming event. Yes.
Yeah. Thank you, everyone. It's my pleasure to have you here. You've had my introduction about my brief essay from Dr. Chan. Thank you for that brief introduction. Yeah, I'll be talking about solar quiet current response in the African sector due to 2009 Sunday stratospheric warming event. Now, these are my outlines. I'll be talking about the forcing on the ionosphere briefly, waves motion in the atmosphere. I'll also talk about the long-term forcing of the atmospheric waves, which is the Sunday stratospheric warming event. I'll talk about some of the forces that is influencing this stratospheric warming event, which is the planetary wave forcing, and what it can induce, like the residual circulation. Now, to talk about some current hypotheses and possible mechanism of coupling between the polar stratosphere and the low latitude ionosphere. Then I'm going to give experimental evidences over Africa. Now, I'm talking about the forcing on the ionosphere. We know that we have the photochemical process, which is very, very significant at the E layer. And then if you go up to the F layer on the top side, we'll be talking about the inclusion of the transport process there. Those are the two things working together at the top side. But in this study, in this talk, I'll be talking about that of the E layer, which is more of the photochemical processes. Now, we talk about different forcing. We talk about the forcing from the above, which includes the magnetospheric coupling that couples the ionosphere. There we talk about the substorms. We also talk about the geomagnetic storms. Now, when we talk from below, the lower atmospheric forcing, there are a lot of transit forcing. Some of them include wave-to-wave interactions. And of course, as regards that, we can have small amplitude, which we call local events like the gravity waves. But when we talk about the long terms of forcing of atmospheric waves, we talk about large amplitude that involves a global event. And that's where the Sunday stratospheric warming event comes into place. Now, these are some of the examples of the wave motion in the atmosphere. We talk about the tides. We talk about the gravity wave, which is just some transient movement of the waves. We also talk about the tides that is a bit longer than the gravity waves. Then we talk about the planetary waves, which is of longer period, that can induce this kind of lower atmospheric forcing that I'm talking about. Then this range from these small turbulence eddies to the thunderstorms, tornadoes, going to the land breeze, then up to the Rossby wave, which can cause this kind of planetary wave I'm talking about. Then, of course, I made a summary to say we have large variety of sources strongly affected by propagation conditions, which can be latitudinal and as well can be seasonal variation. We also have amplitude of waves which exponentially increase with altitude, as you can see from that diagram. Then, while that is happening, we also have deposit momentum and energy at the altitude, and we call it break-off dissipation. Now, the long-term forcing of atmospheric waves, the one that will be used to easily look at the forcing from below, will be the one that will be long-term in nature, and it will be global. And that's why I am considering looking at the Sunday stratospheric warming event, especially that of 2009, because it was recorded as the highest, having the highest planetary wave values. So that's why the decision to look at it over the African sector, if there could be an effect that can influence the SQ current, which is very close to the MLT region. And is the largest known meteorological disturbances due to this planetary wave. And then there's a rapid increase in temperature in high latitude stratosphere of about 25 Kelvin from winter to summertime. It is accompanied by a change in the zonal mean wind, because of course when the...
What data is that?
This is the air temperature.
Air temperature from what are the instruments?
NOAA.
What satellite? Is it a satellite measurement?
Yes, the center measurement from the NOAA.
Which satellite?
Not the satellite, but is the measurement from the site of NOAA, which was used to look at the air stratospheric temperature. And
like the NCAP? It's kind of
yes, NCAP.
Okay.
Yeah. The NCAP from NOAA was used to plot this. Okay. And then we were able to get the planetary waves. Okay. So this plot the stratospheric air temperature here and show the anomalous here around this period, around 2021. And then this is the reversal, the zonal wind mean, which is the opposite of the air temperature. And this is the planetary wave that was gotten as well from the NCAP. And then just give an illustration of the possible mechanism of what the SSW can induce, can cause circulation changes while it is moving from the equator to the poles. It can induce cooling to the warming level and as well at the opposite side. So this can cause a lot of circulation changes between the stratosphere and the mesosphere. Now, I want to talk about some current hypotheses and possible mechanisms of coupling between the polar stratosphere and low latitude ionosphere. These are some of the works that previous researchers have done, and then these references, for example, some of them talk about the non-linear interaction of the planetary waves and tides, and then the lunar tides amplification, and then some of them the TW3 amplifications, the temperature plus wind dynamo, the ozone variation, SW amplification. And from my basis, I look at it and I said, the relative importance of each mechanism is not known. And then all these mechanisms, they can work simultaneously and create complex variation from the stratosphere to the ionosphere. So that depends on what everybody is trying to look at. Now, some connection already established between the solar quiet current and SSW. This is from the literature. Vinet et al. In 2009 talks about the modification of the counter-electrojet and electrojet currents. Feja talked about the modification of CEJ and EJ as well, associated with zonal mean wind reversal and enhancement of lunar semi-diurnal tidal winds. Masaki also talked about the amplification in geomagnetic lunar tidal at Addis Ababa You did a long-term variation of SQ current. And then they also talk about the amplification in EEG associated with counter-electric jet when zonal windmill reverses. At that period, they found out that the EEG current system increased, having additional values beyond the normal values. And then they also found increase in the southern hemisphere.
I'm familiar with the equatorial electric jet. Does the counter electric jet run in the same channel, or does it run external to the equatorial electric jet?
No, it runs in the same
channel?
Yeah, in the same channel. But that is due to the westward electric field in the daytime, not nighttime.
So you basically see a weakening of the equatorial electric jet and call it counter electric.
Exactly.
Okay.
Now I want to talk about the experimental evidences over Africa. Now, just a brief introduction about SQ current. Said it's due to the effect of solar extreme ultraviolet variation while the layer is conducting electrically. Then the tidal wave moves the matter across the field, lines of the main field. And then we have what we call the electric field, an electric current which is recorded over the Earth's surface. You can use magnetometer to do that. Then the equatorial electrical current is an intense band of solar quiet current at E region, altitude of the ionosphere, around 3 degrees north and south, flowing eastward along the dayside deep equator. I gave an illustration here whereby in the northern hemisphere is clockwise, and you can see forming an intense band of the northern hemisphere and that of the southern hemisphere, both of them forming an increased SQ current called EJ current along the equator here. Then further characteristics, like I said, it's an eastward electric current at the equatorial day side of the ionosphere, and this is a typical example of the characteristics, an enhancement in the daytime and it comes down, and this is a typical characteristic of a counter-electric jet in the daytime as well. And this is just showing the map of Africa with the location of the magnetometer that was used in this study. And we have them from the top in Egypt, mapping down through the deep equator and back down to the South African sector here. And then we have about 9 stations here, and that's what we want to look at, the longitudinal variation, and see how the sunny stratospheric warming affect them. Now this shows the stations, shows their geographical coordinate and geomagnetic coordinate, moving from the northern hemisphere into the deep equator and back into the southern hemisphere. And this is showing the geomagnetic condition and the solar flux for the period that we're going to study from January 1 to 31st of 2009. And then between that period, we classify from around 3 January to around 16 January as the precondition for the SSW. And between 16, 17, and 20, I will classify that as the ascending phase of the SSW. And then between 21 and 23, that is the peak phase of the SSW. And then between 24 to around 27, that is the descending phase of the SSW. And then between around 29 to about 26 of February, that is after the SSW. And then from here, which is around 27 to 31st of March, we call it no SSW. And then from the studies and from the previous worker, this sector, this phase, SSW descending phase, was much investigated. And that is when Vinet, Yamasaki, Feja, and all sorts discovered that you have additional SQ current, and then associated with intense counter-electrojet. So that's why we decided to look at other phases if there is going to be other influence. Then this is just showing the error bars of the available data we have used, classifying them into SSW precondition, ascending phase, the peak phase, descending phase, after the SSW, and no SSW. So we have 6 phases of SSW that were investigated. Now this is the result. Now, during the SSW precondition, we found that we have the SQ current intense around the equator, which is, of course, the normal expectation of the result, that we have intense SQ current around the equator because of the movement of the current worldwide around the world. Now, at the ascending phase of the equator, we found out that the SQ current is diffusing in such a way that it's not concentrated again at the deep equator. And then by the time it gets to the peak phase, then we find out that we have a significant reduction in the SQ current here. And apart from that, we also found out that the other reason why we have them having much intensification in the southern hemisphere is now associated with the northern hemisphere, whereby you have more SQ current in the northern hemisphere compared to the southern hemisphere. And of course, what others have got before, intensification of SQ current and as well associated with counter-electrojet, was as well observed during the descending phase. This is what people have got before. And then we also found out that after the SSW, then the SQ current was actually returned back to normal. And then again, when there is no SSW. Then we further take our results on global context to be able to be assured to double check if what we got during the reduction, during the peak phase exactly happens in other equatorial regions. So we go to that extent to look at Huancayo in South American sector. We also go ahead to look at Pohnpei in Oceania, and we also go ahead to look at Trevanium in the Central Asia. So we get similar structure, similar signature, similar to what we got in the African sector. And then, of course, the most interesting that we got in the African sector is the reduction in the SQ current, which we also observed at Huancayo, Pohnpei, and Trevanium, similar to what is observable in the African sector. And as well, during the descending phase, the intensification of SQ current was also obvious in all those 3 sectors. And we also found out that the SQ current, which was influenced by SSW, was more significant in the South African sector compared to the other sectors. And of course, I've made mention a lot as regards my conclusion, and I said the reduction in the SQ magnitude that enveloped the African hemisphere was observed while the stratospheric polar temperature was increasing and got strengthening when the stratospheric temperature reached its maximum. There is a reversal in the north-south asymmetry of the SQH, which is indicative of higher SQH magnitude in the northern hemisphere compared to the southern hemisphere during SSW peak phase. Then the reversal of the counter-electrojet, or CEJ, was observed after the polar stratospheric temperature reached its maximum. Then similar changes were observed in the EEJ at the South America, Pacific Ocean, Central Asia sector. And then we said the effect of the SSW is largest in the South American sector and smallest in the Asia sector. And then, I want to talk about the further effort. What we do was, having found that there is an intrusion truly from the lower atmosphere that invaded the E layer via our investigation through the SQ current. So we go further to look at the GPS tech over the African sector to be able to see if they could go further beyond that E layer, to be able to see the effect. And what we got was very interesting. Of course, the first thing was to do the day-to-day variability of the EIA over Africa to look at the crest in the northern hemisphere and as well to look at the crest in the southern hemisphere and as well to see what happens there. Then what we saw is that around that period, which we classify as the period of the peak phase, there is also reduction of plasma movement from the trough to the hemispheres. And then by that okay. Then we further classify that. The way we classify the order of the SQ current to look at what happens in all those phases. And then, interestingly, the SSW during the peak phase also have plasma reduction. And then, of course, we don't have intensification during the SSW in descending phase. But from us, of course, we don't have much intensification, but we have another crest that is intruding the northern hemisphere and as well moving down into the middle latitudes of the southern hemisphere, more than 30 degrees down into the southern hemisphere. Then ongoing efforts, just to talk about them, validation of AIA with TI-GCM, IRI, and then QUIC models doing SSW, and ionospheric irregularity response to AIA during SSW. Thank you for listening.
Any questions? Yes.
I'm just curious how you put an SSW effect in the TI-GCM.
Yeah.
How are you going to do it?
Right now, I'm trying to look at the TI-GCM, but not fully into it. You know, I'm new into the TI-GCM, so I'm just trying to look at ways how I can use the SSW, taking some parameter from the TI-GCM, for example, the SQ current, because to the best of my knowledge, I know that Yamasaki has done similar things to use TI-GCM to validate SQ current. So I'm looking forward to also do something like that, to be able to look at it over the African sector.
But I'm just curious about all the tides which pertain during the SSW event, how you implement those tides in the TI-GCM.
I think that's a question for the modeler in this room here. you ask.
I mean, you can put in some other model output at the lower boundary of TI-GCM, not with the default version, but Pedatella did this and others, and we have, for another project, we have a version like that. So, I mean, you may lose a little bit something from the tides, but it did show that you get the main effects of the stratospheric warming, and it's better to limit. I mean, especially when you do tidal studies, also you can easily extract some components, so then it has some advantages, and it's easier to run TI-GCM than time-GCM.
Okay.
So, I mean, you might have to modify a little bit of code,
Okay.
but yeah, it's possible.
Thank you.
Other questions? Yes.
There's a very sharp kind of transition. Is that because just the distribution of the GPS receivers?
Yeah.
Like in
The white background?
Yeah.
Yeah, those are days when you don't have data.
They don't have data, but
yeah.
also there's about 6 or 7 north. There's a sharp transition.
Yeah.
So
You know, African, that's the problem, because there's a lot of epileptic supply of electricity.
Oh.
And so many times we battle to put the instrumentation in place, supporting it with some solar panels and also.
So did you look to see if there might be effects related to lunar periods in these
No.
data?
No.
look at the vertical drift von Heckermarker and see if your low TC periods coincide with the low vertical drift periods. I mean, FAIR showed that there is some several day modulation of the vertical drift, that it's low before, then increased, and then low afterwards. And
I didn't take a look at that. If you are talking about the here, for now, this work is just in progress, like I told you, and I'm putting a lot of effort on this work because initially, right now, it's undergoing rigorous review in JGR, and we've been battling with it. But that of the SSWSQ is at the verge of acceptance right now. I've done, but this, I think that's a good idea, and I'll be looking forward to also use that to look at what exactly is responsible for this kind of variation. Yeah.
Question. You have a lot of, since you're the manager of the instrument network, do you have any future plans for instrumentation in Nigeria or something like that?
Yeah.
Tell me a little bit about.
Yeah, we have a lot of plans for instrumentation in Nigeria. As you know, the last time you visited us, we have a lot of instrumentation in place. We have optical imagers recently installed your FPI, and we also have some magnetometers and GPS. Every time we have increment in instrumentation coming up every day. Our government is trying its best to put some other instrumentation in place. And for me, I canvass much about ionosphere and magnetospheric studies and the coupling to the students. And as at now, I can say boldly that we have the largest number of students in the university. Everybody wants to study ionosphere, coupling, and so many other things, because there is now instrumentation to do that, and we have the expertise in place to be able to do a lot of stuff. So thank you.
Another thing, maybe you can tell us a little bit about the universities, your universities, and how many students have. What other colleagues in Nigeria are doing in the field. Just a brief introduction to us, that would be great.
I would love to talk about that. Sincerely, it's not only in America that this kind of science is being done. Yes, I want to say that. We have a lot of colleagues who are studiously involved in these studies. And then, for example, my university, University of Lagos in Nigeria, is the leading university as regards these studies. We have some of them are into some other studies. Some of them are into magnetospheric studies. Some of them are into scintillation and ionospheric irregularities. And then, as regards the number of students, I don't know, but I think we have the largest number of students. For me, I have trained more than 15 MSc students, and then we still have backlog of students. And in fact, we have to do a kind of interview for them to come in, because we have a larger number of students, like I told you, that many of them are now interested in the field because of the instrumentation we now have, because of the expertise we now have. So we have large influx number of students who are ready to do the space science. And then each time we have a lot of headaches for people to come and do the science. So, like I said, I have colleagues, I have senior professors, I have junior colleagues, and I have some of them whom we are contemporaries. But all of us, we work together to make space science a good thing in Nigeria.
So currently, are the data from these instruments public? So do we have access?
Yes,
to
like
the
I
data
said,
everyone?
probably the AFREF, this data was got from the AFREF reference station. This is an upgraded station from the IGS site, where you have African specifically made for Africans. And then we have a lot of data banks there from 2004 to date. You can check it there. It's available.
Other questions? Well,
So even Nigerian data, we are co-opting it into this RFREF, and they are working online fine, and which of course are managing some of those data.
I was wondering what kind of observations do you do with the optical observations? Could you say a little bit more about the optical observations you do, please?
you should know, students are not FIBPRO experts.
I know. She's asking much about the optical imager. Now we are opportune to have the optical imager in Nigeria, the first of its kind in Africa, and then it was installed, given to us by the collaboration between a senior professor, Professor Rabiu, and Professor Shiokawa, Nagoya University of ICEA. So we are opportune to have that. And of course, it's been on. Of course, for each of the instrumentation we have, like I told you that we have a number of students who are ready to do it. So we are always making sure that they are attached to one or two instrumentation, and they are doing a lot of stuff. Right now, the instrumentation is working, but still, the students are working, they are understudying it. It's very new. It was installed last year, June, and they are working vigorously on it. And as well, the FPI installed by Chan, they're also working on it. And then that's why we try to foster this relationship so that we can get better every day.
Anything else? Well, let's thank Dr. Bolaji again.